Hi guys, so today we're doing 7.4, which is the unit circle in 45 degrees. And so we've already kind of seen this a little bit when we did our 45, 45, 90 triangles, and we did the ratio of those. So our ratio was 1x, 1x, 1 square root 2, or x root 2. So then we have that 1 square root 2 ratio. Well, today we're expanding on that and going to do something a little different. We're going to be on the unit circle. And the reason this is called the unit circle is because it has a radius of 1. So in relation to a triangle, what that means is that the hypotenuse of the triangle now must equal 1. Hypotenuse. So if you look down below, you can see all these degrees right here, and these are all cut up in 45 and 45 degree angles, and we're going to be making triangles over those. So we have to be able to convert our ratio of 1 square root 2 to make the hypotenuse of 1 and not the sides of 1. So the way that we do that is we're going to divide everything by square root 2. So again, this is so that we can be on the unit circle and have a radius of 1 because our hypotenuse will always be 1. So that means our hypotenuse is 1, but the sides are 1 over square root 2, and you know we can't leave that like that. So the sides actually end up being root 2 over 2 once we rationalize. So these are some new-ish ratios that you need to memorize. So instead of 1 square root 2, these are the ones you're going to memorize for what we're doing from this point forward. So let's go ahead and take a look at this. If we're at 45 degrees, here's the positive x-axis, here's positive y, this over here would be the negative x-axis, and over here would be the negative y. At 45 degrees, if I draw a 45 degree angle, it's right here. In this quadrant, quadrant 1, everything, every x and every y is positive. So when I take my new ratios that I just wrote down, remember that unit circle would mean that that radius has to be 1. And because this is a 45 degree angle, these sides are root 2 over 2. Okay, so those are both positive. Then we move to our next 45 degree angle, which is 135, and you're like, you said 45. 45 degree reference angle. So we've already talked about reference angles. They get us back to the x-axis. So if I graph 135, it's right here. And then I drop my triangle down. So here is that radius. It's always 1. You don't have to worry about positive or negative. It's always 1. This height is root 2 over 2 because I'm above the x-axis. But guess what? This side right here is negative root 2 over 2 because I'm to the left, right? And if I'm to the left, then it's going to be negative. All right, moving on to the next one. 225 degrees. When I graph that, I end up right here. My reference angle, though, the little angle that connects me back to the x-axis, is 45 degrees. Now the radius or hypotenuse is 1 because we're on the unit circle, but this is negative root 2 over 2, and so is this guy. Why are they both negative? Because this one's to the left of the y-axis and this one is below the x-axis. Okay? So it's those same ratios, and it's a little annoying, but if you ever forget, you can always just convert like we did right there. And then on this last one, 315 degrees is all the way right here. And then I connect it to the x-axis. My radius is 1, aka my hypotenuse. This is positive root 2 over 2, and this is negative root 2 over 2. So just to summarize that real quick, if I am in this quadrant, let's say quadrant 3, both my x and my y's are going to be negative. If I'm over here, my x is going to be negative, but my y value is going to be positive. And if I'm down in quadrant 4, my x is positive and my y value is negative. Okay? So now what we're going to do is evaluate some trig functions at certain angles, and they're rigged to be 45-degree angles, so we get practice with these. So here are our steps. Step 1 is to draw the angle. Step 2 is make the triangle with the x-axis so that we get the reference angle. Step 4 is to label the triangle with your special triangle ratios. And then step 5 is to do Sohcahtoa. And then step 6 is just to make sure you've checked your sines. Okay? So watch. Sine of 45 degrees. First thing I'm going to do is graph a beautiful 45-degree angle right there. Step 2, I'm going to make a triangle with the x-axis. So that's going down to the x-axis. I know that this is 45 degrees because I just drew it. So if I label my sides, that's root 2 over 2, that's root 2 over 2, and that's 1. So this is steps 3 and 4. Step 5 is to do Sohcahtoa. So where it says evaluate, you might want to write this. Sohcahtoa. We've already practiced that too, but we'll write it in there. So the sine of 45 degrees, sine is opposite over hypotenuse. What you'll also notice is that it's the height or the y value of your triangle over the r value. So I'm going to write that in there just so that we start making some more connections. And that would be root 2 over 2 over 1. And root 2 over 2 over 1 is just equal to root 2 over 2. See, because it's opposite over hypotenuse. Okay, next one, secant of 135. Okay, so step 1, graph the 135. Bisecting quadrant 2. Step 2, drop it down to the x-axis. That's a 45-degree angle. The positive root 2 over 2, and remember, the hypotenuse is always positive 1. And then this guy, though, is negative root 2 over 2. So secant goes with cosine, so it's the reciprocal of cosine, so it's hypotenuse over adjacent. So I take the hypotenuse, which is 1, over the adjacent reference angle, so that's negative root 2 over 2. And how do I do that? Whenever you have this in math, you're going to copy and then dot flip, and you always flip the second one. And then we just got to simplify that. So that's root 2 over root 2, and we know it's going to be negative. So that equals 2 root 2 negative 2 root 2 over 2. And those cancel. So this just simplifies to negative root 2. So all this work is not this chapter. This is just a review of some algebra skills that you learned a while ago. So just keep that in mind. Cosine of 225. Okay, 225 is here. You draw your angle. And we are always connecting to the x-axis. So that's another 45-degree reference angle. So because that's 45 degrees, these are root 2 over 2's, but they're both negative because of where they're landing. That's 1. Cosine is adjacent over hypotenuse, which adjacent is the one touching, so it's going to be negative root 2 over 2. But what you'll also notice, if this was like a circle, like these ones over here, it would be the x value over your radius. And remember, no matter what, the r value or the hypotenuse is always positive. So then I'm going to get negative root 2 over 2 over 1, which is nice. That just simplifies to negative root 2 over 2. Alright, next one, sine of negative 45 degrees. The only thing different is when we graph the angle, we go down instead of up. So I'm going to go down this way, bisect that angle, then I'm going to go ahead and drop it down, label with appropriate signs, negative root 2 over 2 because it's down. This one's to the right, so it's positive. Hypotenuse is always positive. Sine is opposite over hypotenuse, or the height over the radius. So this one is going to be negative root 2 over 2 over 1, which is negative root 2 over 2. We're going to see a lot of negative root 2 over 2's here because of it being a 45-45 triangle setup here on this entire lesson. Tangent of 405 degrees. So we got 90, 180, 270, 360, and 405. From 360 to 405, it's another 45 degrees. Again, these are rigged. Draw my angle, make my triangle. The reference angle inside that triangle is a 45-degree angle. So these are the sides. And then tangent is equal to opposite over adjacent, which is the same thing actually as your y value over, not your r value, your x value. Give me one sec. So that's y over x. So look at the triangle when I say that. Opposite is the height, so that's why it's the y value. Adjacent to this angle right here is the x, so that's why it's the a value. Which equals root 2 over 2 over root 2 over 2, which is just going to equal 1, because anything divided by itself is 1. And then secant of negative 495. Great. So we have negative 360 is one trip. And then when I do this, I just like to go by 9. So 36, this is 45 or 450. And then that would be 495. So I end up down there in quadrant 3. And because I'm in quadrant 3, both my signs are negative. But my hypotenuse is always 1. And then secant, we already did. We'll do it again. It is hypotenuse over adjacent, or the radius over the x value. And you guys might be wondering, like, why do I keep doing this? Because there's going to be a point in our chapter where we have to use r over x and y instead of h and a. So I'm kind of just introducing it to you right now. So the hypotenuse is always the radius, and then the x value is your adjacent value. So that gives me 1 over negative root 2 over 2. And then we're going to copy dot flip that. So that's 1 times 2 over negative root 2. Rationalize the negative as long as you just have it in the problem once. Then you are good to go. So that's negative root 2. We know it should be negative because we only have one negative. If we miraculously threw in another negative, then a negative divided by a negative would be a positive, so that wouldn't work. Alright, let's flip it over and work on radians now. So we've done some work with the unit circle, and we're just going to recap really fast. So here is 0. If you take one whole trip around, it's also 2 pi. So if you only go halfway, that's pi. And if you only go a quarter of the way, that's pi over 2. But 45 degrees is right here. So what's half of a half? That would be pi over 4. So go ahead and write pi over 4 right there. So if your reference angle is pi over 4, you drop it down, and then it's just like the 45, root 2 over 2, root 2 over 2. Okay, both are positive. Then when you go to the next one, you're going all the way to here. Here's 135 degrees. So if you're at 135 degrees, you're at this third line. Well, this is 1/4, this is 2/4, so that guy must be 3/4. So that's 3 pi over 4. I'm just going to keep going with labeling them in radians. So then this one was pi, so 1, 2, 3, 4. When I go to do 225, which is this guy right here, that's going to be 5 pi over 4. And then I keep going and I get 6 pi over 4 at this spot, which is 3 pi over 2, and then 315 degrees gets me all the way to here, and that's 7 pi over 4. You can see it's cut into 8 pieces. You're just counting the number of pieces, keeping in mind that this is pi. Halfway is pi, so that'd be like 4 out of 4, and then over here would be 8 out of 4 since it's 2 pi. So you're just counting the fourths when you're doing 45-degree angles. Okay, I'm just going to label these triangles again like we did in the last one. So I'm just going to go a little quicker though, because they're exactly the same angles that we did on the front side, but we're in radians instead of in degrees. Okay? So negative root 2 over 2, negative root 2 over 2, both of these are negative, and then only that one's negative here. Okay? 1, root 2 over 2, 1, 1, root 2 over 2. Okay? So obviously you can pause the video if that went too fast, but we're just going to move on now. So sine of 5 pi over 4, it's the same stuff over and over again. Here's my tip: if I'm asking you to graph 5 pi over 4, you know this is pi, change it to whatever your denominator is. So 4 out of 4 pi, that's still pi. So 5 pi over 4 is 1 1/4 of pi. So I'm going to go all the way to 4 out of 4, but then I have one more. So I'm going to end up right here. And then I'm going to connect it. I'm going to label my sides because it's a pi over 4. That's a 45 degrees. So then my triangle looks like this. The sine is going to be opposite over hypotenuse, or y over r, which is, y value is the height of the triangle, negative root 2 over 2. Over 1, which is negative root 2 over 2. Okay, next one is cotangent of 11 pi over 4. Alright, so this is 4 pi over 4. There's 4. This is 8 pi over 4. So now I'm at 8 pi, or 2 pi. And then I have 3 more. So here's 1/4, 2/4, 3/4. So that would give me 11 pi over 4. Or if you want, you can do 2 3/4 of pi is another way to write that. So this is 2 pi, and then 3/4 will get you to where it's at. Drop it down, 1 root 2 over 2, and then negative root 2 over 2. And then what are we doing? Cotangent. Cotangent is the reciprocal of tangent, so it's x over y. So we have the x is the base of our triangle, so negative root 2 over 2, all over root 2 over 2, and a negative divided by a positive is going to be a negative, and it's going to be 1. Okay, next guy is up here. Cosine of negative 3 pi over 4. So negative 3 pi over 4 is going to be right there, because this is negative 4 pi over 4, and I'm not all the way to a full 4 out of 4. So here I am. It's the same thing. We're just going to label negative root 2 over 2, negative root 2 over 2, and this is 1. Cosine is adjacent over hypotenuse, or x over r. So if I do the x, it's going to be negative root 2 over 2. And then the r, or the hypotenuse, is 1. So that's negative root 2 over 2. Okay, moving on. Again, if I'm going fast, it's the beauty of YouTube. You just pause it, or you can even play it at a slower speed. Make me sound a little funny, but I don't mind. So we're going negative, so I'm labeling this pi, but I'm doing negative 4 out of 4. But this is negative 9 out of 4. So the next multiple would be negative 8 pi over 4, and then I have one more. So this is negative 2 and 1/4. So that's telling me I need to do one whole circle and then a little bit more. And then we label it with the appropriate signs. This guy is negative. And then sine is opposite over hypotenuse, or y over r, which is negative root 2 over 2 all over 1, which is negative root 2 over 2. So fun, especially when you get to use different colored pens. Great. All right, cosine, last one, negative 13 pi over 4. 4, 8, 12. So this is negative 3 and 1/4 of pi. So here's negative 1. Then I'm going to do negative 2. So that's negative 2 pi. Then I do negative 3 pi, and then just 1/4 of the top part. So right here. So there's another way that you can do it. And then we're going to label 1 root 2 over 2. You get so good at these. It's when we start mixing in the other special triangles that it gets a little challenging. You just have to slow down and take your time. Cosine is adjacent over hypotenuse, or x over r. I love it when it's x over r and we're on the unit circle, because r is always equal to 1. So then it's just the x value. So this is just negative root 2 over 2. Over 1. That's the beauty of the unit circle. If you are doing sine or cosine, it's always just going to be that value, the x value or the y value if it's sine. But if you're not on the unit circle, it doesn't always work out. Alrighty, so that was our 45, 45, 90 on the unit circle. Our next lesson will be 30, 60, 90 on the unit circle.